This is semester 2, first 9 weeks, practice A, problem number 8. The name of this problem is multiply monomials. Multiply monomials. And the description would be multiply coefficients. What are coefficients? What are those?
They're the numbers that aren't variables.
The numbers that are in front of the variables. So multiply coefficients, multiply variables, by adding exponents, and rewrite with new powers. And that last part, you may not have to do. It may work itself out that after you multiply coefficients and multiply variables, you're done. All right, so it says to simplify. The first monomial is 7c to the third d to the fourth times the second monomial, negative 4c d to the third. So step 1, multiply coefficients. That means I need to take 7 times negative 4, which would be negative 28. And then from there, I match up the variables. In the first monomial, I got c to the third. In the second one, I have c. What's the exponent on that second one?
0.
Not 0.
1.
1. So c to the third and c to the first would make it c to the fourth. And then you switch to the d. I've got d to the fourth and d to the third. It would make it d to the seventh. It says rewrite with new powers, but there is no need on this one. You're done. So negative 28, c to the fourth, d to the seventh. That's all you do. Questions?
Wow.
All right, we're going to go ahead and do number 9. And number 9 is divide monomials. And this time we are going to, for the description, reduce coefficients. You're going to cancel common variables. And then rewrite with new powers. Now these you will rewrite. So you're going to divide monomials, and these problems can be given to you looking like a fraction like that, or they could actually take a monomial, put a division sign in the middle, and another monomial. But definitely the fraction way is a lot quicker and easier. I would even recommend that if they give you that division problem, rewrite it like this. It goes a lot quicker. We're going to reduce the coefficients, cancel the common variables, and rewrite with new power. So it says to simplify. I've got 18x to the third, y to the fourth, z to the seventh, over negative 2x squared y z. So there at the original problem is where I'm going to do a lot of the work right now. And I've got, first of all, a positive over a negative. So one of each, a positive divided by a negative. So the final answer is going to be what? Negative. If the signs are the same, it's positive. If the signs are different, it's negative. 18 on top and 2 on the bottom. It's just like any other canceling. You're going to divide out 2, and you're going to be left with 9 on top and 1 on the bottom. Then you switch to the x's. There are 3 on top and 2 on the bottom. How many can I cancel out completely, Natalie? So these 2 are gone on the bottom, and on the top I'm left with, my 3 becomes a 1. Y's, I've got 4 y's on the top and 1 on the bottom. So how many can I cancel out? Only 1, so the 1 on the bottom's gone completely, and my 4 on top becomes a 3. And the z's, I have 7 on top and 1 on the bottom. I can cancel out this one completely, and my 7 becomes a 6. Okay, it looks like everything really canceled out on the bottom. That's not always going to happen. But since it did, that would only leave a 1 on the bottom, and you don't write 1s on the bottom. So this is negative 9x y to the 3rd z to the 6th. Negative 9 x y to the 3rd z to the 6th. Number 10 is taking, or it says simplify n to the 3rd power in parentheses to the 4th power. This name is called power of a power. Power of a power. And the description is multiply exponents and rewrite with new power. Multiply exponents and rewrite with new power. Now, if there would be something in there besides just n cubed, everything in there would have to go to the 4th power, but most of these are just going to be pretty simple. N to the 3rd to the 4th would be n to the 12th, and you're done. All right, number 11. It says simplify and put in standard form, and it's 2 polynomials. In this one, they're subtracting them, okay? Sometimes you would be adding them in the middle, but number 11 is called combine polynomials. Combine polynomials. So when they use the word combine in these sheets, he's really implying what we used to call add or subtract, but we're combining them. Okay, so this one says for the description, distribute if needed. Distribute if needed. That means if there's something out in front of one of the parentheses, you distribute through, and then combine like terms. Distribute if needed, then combine like terms. Okay, here's the thing that he's mainly talking about, and that is this minus right here. This is a distributive needed, because what number is appearing in front of that polynomial that would change what's in there? Matthew?
A 1.
Not just a 1. A negative 1, and that makes a big difference. So when it says distribute if needed, if there is a minus there, the distributive is needed. So you're going to rewrite doing this. You're going to write the first one as is, 5x squared minus 6x plus 1. And then you're going to distribute a negative 1 through the second polynomial, which in essence just changes every sign. So minus 2x squared minus x plus 7. Okay, something I want to point out to you before we go any further is this right here, standard form. The standard form of a polynomial is taking the variables from the highest exponent down to the lowest exponent. So in this one, the highest exponent is what? 2. So you'd have to put your squared term first, your x to the 1st power second, and then your constant term last. That's standard form. So whatever the highest exponent is, it has to come first, and then you go in descending order. So combining these, I've got 5x squared minus 2x squared, which is... Oh, you had a question. What's your question? Two different variables? then they would tell you which one to go by, or you would usually always try to go with the X or alphabetical order. Okay? All right, so after you get the distributive done, combining means that anything with the common exponent needs to be combined together. There can only be one of each one remaining. So we've got a 5x squared and a minus 2x squared, or negative 2x squared. So when we combine that, that's going to be 3x squared. Then you go to the x term. I've got negative 6x and negative 1x. That would be negative 7x. And the constant term would be 1 and 7, so that's 8. So 3x squared minus 7x plus 8. So we're going to multiply these binomials, 3x minus 2 times x plus 5. We're going to apply what's called the FOIL method and then combine like terms. So off to the side, if you would, FOIL method, F-O-I-L, stands for first, outer, inner, last. First, outer, inner, last. And that's how you multiply binomials. First, outer, inner, last. So let's look at this and see what first, outer, inner, last actually means. When I'm looking at the two binomials, 3x minus 2 and x plus 5, if I go with first, it means the first term in each binomial. So that's the 3x times the x. So my first is 3x times x, which is 3x to the second. When it goes to outer, outer means the outside terms in both. So if you look left to right across that problem, the outer would be 3x and 5. That's my O, that's my outer. And 3x times 5 is 15x. Inner, if I look left to right across those four terms, the two on the inner inside, or the two inner, would be negative 2x, negative 2 and x, so negative 2x. That's my inner. And my last would be the last term in each parentheses, which would be the negative 2 and the 5. That's my last, the last one in each. And what is negative 2 times 5?
Negative 10.
Negative 10. So I have multiplied with the FOIL method, first, outer, inner, last, and then combine like terms. Almost every time. Almost. Now notice I didn't say every time. Almost every time. These two terms in the middle will be like terms, just as they are right here. And you must combine them. Do not leave them separate. So my final answer, 3x squared plus 13x minus 10. It should come out to a trinomial, 3 terms. Trinomial.